Hello everyone, in this video we're going to discuss 4 questions, which is question number 23, 24, 25 and also 26. Now let's go. For this question, the tension in a stretch string is 50 centimeters. So I'm going to straight away do the listing, which is 0.5 meters. And then we also have the mass, which is 1 gram. So it is 0.001 kilograms. Next, we have a tension of 100 Newton. Okay, 100 Newton. What else? Yada, yada, yada. Okay, that's it. So question A is asking for the transverse wave. So don't worry, transverse wave for the stretch string is very easy. It is here in the note. So V equals to T over mu. Now, because we know the mu is M over L, I'm just gonna infuse it into our equation. So it is T over mass over length, like that. So the answer is 223.6 meter per second. Question B is asking for fundamental frequency. So it is F1. B is F1. We know the equation for fundamental frequency, the nth harmonic. So in this case, it's Fn equals to Nv over 2L, right? So F1 equals to 1 V over 2L. So V we can get from the transverse wave, and then the L, well, you can get the L from here. So the answer is 223.6 Hertz. Question C, wavelength. We have to find the wavelength of the note. Okay, here it is. This is wavelength of the note. This is not from transverse wave. Transverse, bukan, okay? Because we are talking about note. Remember in the previous video that I mentioned about when the string is vibrating, it has its own velocity, but as it travels through the air and hits our ear, you are hearing notes. So this one is actually the wavelength of the note. Now it vibrates on the second overtone. So for the second overtone, for the stretch string, it is actually F3 lah. So since we know that F3 equals to 3 times F1, we know the F1 that we got in question B is 223.6. The answer is 607.8 Hertz. And from here, we can use the frequency to get our lambda. The V equals to F lambda is not the V that we got from the transverse wave. Now this one comes from the sound, the speed of sound in the air. So we're going to use this one. 330 equals to 670.8 times lambda. Hence our lambda is 0.492 meters. Now let's go to question number 24A. Determine the frequency of the third overtone produced by air column vibrating in an open pipe of length 1 meters. So question number A, we have 1 meters as the length. So let's go for the third overtone. What harmonic is that? We can refer to the table in my notes. You can see that for the third overtone, it is F4. Third overtone is F4, and the equation is Fn equals to Nv over 2L. So I wrote here third overtone is F4. So from here, based on the equation, I can say that F4 equals to 4 V over 2L. Now, unlike stretch string, which has transverse wave, this one we are talking about air column. Air column has no transverse wave. So straight away, we're going to use the V from the speed of sound. So the answer is 660 Hertz. Now let's go to question B. The frequency of the fourth overtone produced by an open pipe of length 1 meter is equal to the frequency of the third overtone produced by a closed pipe. Now we have to determine the length of the closed pipe. Now this is a little bit confusing, but we can refer to our table again. So here we have, it says here fourth overtone of the open pipe first. Based on this table, we can see that the fourth overtone for the open ends pipe is F5, and the equation is this one. So I wrote it like this. And then we can see that it says that the frequency of the third overtone for the closed pipe. So based on this, third overtone for the closed end pipe is F7. So I wrote it like this. And because the question says that these two, F5 and F7, are equal, so I wrote it like this. I'm going to combine these two, 5V over 2L equals to 7V over 4L. And because I know speed of sound in the air is the same, this one becomes 2, this one is gone. Okay, we are looking for the someone's L. Let's see. We have to find the length for the closed pipe. So this is the closed pipe. And what about the L of this one? We have here 1 meters. So it is 5 over 1 equals to 7 over 2L. So L equals to 0.7 meters. Now let's go to question number 25A. A stretch wire 80 centimeters and a mass of 15 grams vibrates transversely. Okay, we have a stretch string, no problem. We have two V's. Waves travel along the wire, so this is definitely a transverse wave. It's 2 to 0 meter per second. We have two antinodes can be found in the stationary waves form in between two fixed ends of the wire. So this is a standard. Determine the wavelength of the progressive wave which move along the wire. So first things first, I'm going to do the listing. I have length. I'm going to change it into SI unit. So as the mass, okay, the speed is 220 meters. This is a transverse. Okay, and it says here that this is two antinodes, right? So for two antinodes, let's see. I have it. So it's basically the first overtone. So first overtone is a second harmonic. So first overtone sama dengan second harmonic. Question number 1 is asking for the wavelength of the progressive wave. The nice thing about the first overtone, this is exactly the lambda. So we can say that the L is the lambda itself. It's quite easy if you are dealing with the second overtone. So L equals to lambda, hence lambda sama dengan 0.8 meter. Senang kan? Next, number 2. It's the question is asking for the frequency of the vibration of the wire. So easy, we're going to use F2 equals to 2V over 2L. Okay, so the V is 220. Remember that this is a transverse wave, right? 0.8. Hence the answer is 275 Hertz. Question number 3 is asking for the tension of the wire. The only way that we can find the tension is when we use this equation. So let's do it. Since velocity equals to square root tension over mu, and we know mu is mass over length, I'm going to straight away put it into like this. You should get 907.5 Newton. Next, we go to question number 25B. 3 antinodes can be found in the air column vibrating in resonance in an open pipe. 3 antinodes. Okay, you can either sketch, or you can just refer to this. So for 3 antinodes, it's basically first overtone. Here we have 1, 2, 3 antinodes for the open pipe. So 3 antinodes gonna give a second harmonic. So I wrote it like this. It is 600 Hz. The question is asking for fundamental frequency. The basic equation for the open ends pipe is Fn equals to N(F1). So I can just use F2 equals to 2F1. We want to get the fundamental frequency, right? So F1 equals to 600 divided by 2. So we straight away get 300 Hz. Next, the question is asking for the length of the pipe. So for the length of the pipe, we're going to use, because this is a the first overtone, it is basically F equals to V over L straight away. So our L is 0.55 meters. Question number 26. A glass tube is closed at one end. Okay, we are going to refer to this part of the note. Okay. The air column it has a length of that can be varied between 0.5 meters to 1.5 meters. If the tuning fork, it's actually a tuning fork of the frequency 306 Hz is sounded at the top of the tube, at which length of the air column would resonance occur? So we're going to use the speed of sound 330. So the situation is basically like this. So when you move this pipe, the water inside here will start to rise, and the water inside here also will start to rise, and then you will hear which one has a louder sound. It's like boom, like that. Okay, so we're gonna find at which frequency it will start to, at which harmony it will start to resonate. The length is in between 0.5 to 1.5 meters. Frequency provided is 306 Hz. So now kita akan buat trial and error. Because this is a closed-end pipe, the basic harmonic equation is Fn equals to Nv over 4L. We're going to use this equation, okay? We're going to use F1 equals to 1 times V over 4L. The V is the speed of sound in the air. So L equals to 0.27 meters. So this is rejected because it is not within the 0.7 length. Now let's try second because it doesn't have any second harmony, it's jumped to, not this one, it straight away jumped to the third harmony. So we're gonna try third harmony instead. So this is 330 over 4L. Let's calculate, and you should get L equals to 0.8 meters. So this one is accepted. Okay, let's continue because we don't know whether they're gonna resonate again. So let's try to, because this is open closed end pipe, it's gonna jump straight away to F5, not F4. Okay, so F5 equals to 5 times 330 over 4L, and your L should be 1.35 meters. Well, 1.35 is still within the range of 1.5, so I'm gonna accept this one. So it's again, it's gonna jump to, here we have F1 we are done, F3 we have done, F5 too, and now we have to go for F7. Okay, seventh harmony. F7 equals to 7 times 330 over 4L, and your L is 1.89 meters. Okay, now this one has to be rejected. It is already out of the bound. So the resonance occurs at 0.8 meters and 1.35 meters.